Exercise 4.3 takes a look at interpolation versus extrapolation. So what do they mean? Interpolation and extrapolation is just a way of explaining how we predict values using the line of best fit. So how we do that, we plug in the values into the X and Y, or the response and explanatory variables, and then from that equation we'll get the opposite variables answer. And so interpolation is when we predict within the original data range. Extrapolation is when we use that line to predict outside of the collected data's range. It's really important to note that predictions based on extrapolation are not as reliable as those based on interpolation, because we cannot be certain that the equation applies to values outside the range of data values we have. For example, if we had year at the x-axis, for example, right now we're in 2020, and if we had age on the y-axis, do you agree that we've got a perfectly linear relationship in the positive direction? Yes. For example, in 2020, I'm 25. In 2021, I'm 26. In 2022, I'm 27. We can start creating a line of best fit, and we can figure out, well, it's just plus 1 each year. But obviously when it's 2,150, okay, I'm not going to be 155 years old, am I? I'm probably going to be dead. So, well, pretty much guaranteed to be dead. So that's the issue with extrapolation. There comes a point where that line stops applying to the data points because we're not sure if it actually continues forever. Okay, so interpolation is a lot more reliable than extrapolation. How do we do this by CAS? Well, it's pretty simple. You just find your rule or your least squares line of best fit. And if you were, for example, here asked to find the age of someone that is approximately 155 centimeters tall, you would type in solve, brackets, sub in 155 to where the height is. Okay, and then let's just highlight this. So we're aware, so here's height, here's 155, we've subbed it in, and then you fill out the rest of the equation, type out age, then comma age to figure out your age, which is roughly 22. Now we all know that there's 22-year-olds who might be taller and shorter, but this is the rough estimate based on the data we've collected, and this is the one that we came up with. How do we calculate all this by hand? Well, if you were to go by hand, it's just back to the algebra days where we substituted the values in. So if this is our formula here, so we've got height, okay, and then we've got age. Those are our two variables. Height is our response variable, age is our explanatory variable. Here it says predict the height of a 15-year-old. Keep in mind, our data set is collected from years 7 to 19 years of age. So anything outside of 7 and 19 would be considered extrapolation. Anything inside is interpolation. So if we have a 15-year-old, we know this is an explanatory variable. We would sub the 15 to where the age would go. We calculate the right side in our CAS calculator and we get 165 centimeters. So as a 15-year-old is inside the original data range of 7 to 19, which is what we underlined up top, this data is considered interpolation. If we were to predict the height of a 24-year-old, all of a sudden we'd be doing extrapolation because we're now outside of the data range we collected. So predict the height of a 24-year-old. Well, remember we had yellow and green. for age and height. Here we sub in 24, and if we plug the right side into our CAS calculator, we're figuring out this is extrapolation because it's going to be extrapolation because it's outside the 7 to 19 years range. Next one, which of the predictions in parts A and B is more reliable? It's always going to be interpolation. So part A, because the 15-year-old is actually in that data set we collected. A 24-year-old is what we're speculating if the trend continued beyond 19 years of age. Obviously, 210 centimeters for a 24-year-old, right? Like you're almost a legitimate footer, 7-footer. So that's that's pretty unlikely to be the average for a 24-year-old. So that's highlighting the inaccuracy of the line beyond the age of 19. Lastly, predict the age of a person of height 145 centimeters. So this time round, height 145. Okay, you can just put this into your CAS, or you can do it by hand. So down here we've got the by hand version. If you type in what we typed in above, back up top here, okay, where you type in solve, 145, you'll get your answer straight away. But down here, you've got the working out by hand. So either way is fine, depending on whichever you find is quicker. Again, there's no extra marks to do it by hand. There's no extra marks to do it by CAS. Whichever you prefer is your best method. That's all for exercise 4.3. Let me know if you have any questions.